Hello everyone, I'm Singh Gambhir, third year student at the IIT Allahabad. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, this is one-stop destination for you. Every week we will be posting explanations to CodeChef problems, conceptual videos, and also conduct live problem solving sessions. Before we get started, make sure to hit the subscribe button. Did you know that CodeChef also conduct free live classes on an academy where we teach every possible topic related to competitive programming? These courses are conducted by top coding experts who have been ICPC World finalists and are also highly rated on various coding websites. You can use my referral code MEET10 to subscribe and get an instant 10% off. Today we have the problem named low budget sanitization, which is a medium level interactive problem, and it is not inclined to a particular topic. It is a general problem where the concept of linear equations and also some of the concept of geometry are required. Let's see the problem statement for the low budget sanitization. Chef found a dirty looking square plate in its kitchen. Obviously, it is full of germs. So, there are specifically n germs lying in the whole plate. The plate has the dimensions m cross n and can be imagined as a two-dimensional square space bounded by the line x, 0, y, 0, x is equals to m and y is equals to m. So, basically, the area in consideration is of the square, which we can say starting from the left corner as the 0, 0 and the rightmost top corner as the m, m. Chef knows that each germ lie at a point with integer coordinates within its plate and no two germ lie at the same particular point. But he doesn't know the exact location of the germs. Each germ has a unique ID between 1 and n. Chef wants to sanitize this plate, that is make it germ free. But because of low budget, he can afford only n ml of sanitization. Each germ required 1 ml of sanitize to be killed. So he needs to be careful not to waste even a single drop of it. So we need to determine where a particular germ is located and then we will sanitize that particular germ, and we do not have any extra sanitizer, so we need to be sure that a particular germ is located at that particular position only where we are sanitizing, because we cannot afford to lose any sort of sanitizer. Luckily, he has also a germ sensor with him which works as follows. It sends a laser beam of light along the straight line ax plus by is equals to c and returns two things: the ID of the germ having the shortest perpendicular distance to this line. If there are multiple such germs, any of them may be chosen. The distance of this germ from the line. So the sensor works as follows: that we will send a laser beam of light along this particular line ax plus by plus c, and then in return we will have the ID of that particular germ which has the shortest distance and also that particular distance which is obviously the minimum distance among all the germs possible for this particular line. But again, because of low budget, he is using a cheap model which can be used at most 2n times. So we can ask this particular thing at most 2n times for n germs. Help him kill all the germs. You can use the sensor or apply sanitizer in arbitrary order. Note that the sensor does not sense the killed germ. So suppose you have killed a particular germ, then in the upcoming, when you are applying the sensor, it will not detect that particular germ. If you want to use the sensor, then we need to print a single line containing 4 space separated integers 1 a b c, and this is the constraint that the value of ab should be in the range from -128 to 128, where the line represented is ax plus by is equals to c. And now out of the remaining possible germs which are not killed yet, the grader will take all of the germs, and that particular germ which has the minimum perpendicular distance from this particular line, that particular germ's ID will be reported, and also the distance which is the perpendicular minimum distance of that ID multiplied by this term which is under root of a square plus b square, it will be given as the output. So for the first query we have the two outputs, ID as well as the minimum perpendicular distance multiplied by this particular term. And if you are sure that you know the exact location for a particular germ, then we can apply 1 ml of sanitizer at that particular point. And to do so, we need to have the second type of query, which is 3 space separated integers 2 followed by x and followed by y, where x and y represents that coordinates where we want to apply the sanitizer in order to kill the germ. And in the end, maximum we can do is apply the 2n type of queries for the first type and n times apply the sanitizer in order to kill all of the n germs. So before coming on to the actual main solution, let us frame some points which will be very helpful for us to proceed in this particular question. Now suppose that you have applied a query of the first type. So you will give A, B and C, and then the grader, it will return the ID of that particular jump which has the minimum distance from this particular line, which is AX plus BY is equals to C, and also the minimum distance. Now if you have seen the question properly, then it will not give the distance directly. We will have a term which will be distance multiply a term which is a square plus b squares square root. These a and b are same as these a and b which we will be giving in the query for the first time. Now if you are familiar how to calculate the minimum perpendicular distance of a point x1 y1 from the line ax plus by is equals to c, so it will come out to be absolute value of ax1 plus by1 minus c divided by a square plus b square root. You see that this particular term, which is a square plus b square square root, it will be always positive, so we can remove it from the absolute value. So we can have absolute value of ax1 plus by1 minus c divided by a square plus b square. This will be the distance. Now the grader, as it is giving distance multiplied by root of a square plus b square. The output for the first type of query, it will be id followed by the distance, which will be nothing but absolute value of ax1 plus by1 minus c. We are asking the query of the first type. The grader will return nothing but the minimum possible values for this particular term, which is the absolute value of ax1 plus by1 minus c, where x1 y1 represents the coordinates of all the possible jumps which are not being killed yet, and also we will be provided the id of that particular jump which has the minimum value for this particular term. So what actually happens when we ask a query for the values a1, b1 and c1, the grader will return us the id as well as the distance of that particular point which has the minimum distance. So this value, as we have already seen, it is nothing but the absolute value of a1 x of that particular jump which id has been given to us plus b1 y of that particular id minus c1, and as it is given to us, it will be equal to d1. So what is this particular thing? This is nothing but an equation in two variables, where xid and yid are the two variables, and the rest other things which are a1, b1 and c1, also d1, these are known to us. a1, b1, c1 will be given by us as the input, and the d1 is the thing which will be written as the output to us by the grader. So the only two unknown variables here are the xid and yid, which represents the x coordinate of that particular jump which has the id, and similarly yid represents the y coordinate of that particular jump. Now the final aim, it is same to determine the xid and yid so that we can sanitize those coordinates. But there is one problem here, that there are two unknowns but we have only one equation, so we cannot have the exact value or the unique value of xid and yid possible in this particular case. So we need to have one another equation in the same variables only, so that we can uniquely determine the values of xid and yid. So suppose that we again apply the query for the first type, now with the different values of a, b and c. So suppose that we apply the query with the values a2, b2 and c2. So again we have the values of the absolute value of a2 xid plus b2 times yid minus c2, and it is equals to d2. Now if we see that we have two equations in two variables which are xid and yid, now we can determine the xid and yid with the help of these two equations only. And also it is possible because we have in total n number of jumps and we require two queries for each of the jump. So in total we will not be exceeding in total 2n number of queries. So this is possible. But we have furthermore some sort of problems for this particular method. Let us see how we could solve them. So the first problem is that we do not want to have the same ID more than two times. Because if it is the case, then what happens? We are short of the queries. We could not complete our task in 2n number of queries. So in order to solve this particular difficulty, what we can do is we will ask queries, and soon as we have two equations for the same particular ID, then we will determine the values of x and y coordinate of that particular jump's ID, and then we will sanitize that particular jump, so that when we will be asking the further more queries, that particular ID will not be given to us as the output, because that particular jump has already been killed. So it ensures that we are asking no more than two queries for each particular ID, as there are n possible options for each of the ID. So in total we will never cross 2n number of queries. The another problem here is that how do we use this particular equation to calculate the xid and yid? The second thing is that how the absolute function will be open, because there is the problem here. The absolute value of a particular number x, it is defined as x if x is greater than equals to 0, and it will be minus x if x is less than 0. So here, how do we get to know that we will open this particular absolute value as the x or the negative of this term only? So we need to ensure that we know this particular inequality, that either this particular term should be greater than equals to 0 or it should be less than 0. Let us see how we can do this particular thing. So we have the term as a1 xid plus b1 yid minus c1, and now we have to comment on its inequality with respect to 0. So if you see that the range for the xid, it will be from the range 0 to m, because it represents the x coordinate of a particular jump. Similarly, the yid, it will also be in the range of 0 to m only. So now suppose you take a1 greater than equals to 0. Similarly, if we take b1 as greater than equals to 0, and we would take c1 as less than equals to 0, and in that case it will be obviously ensured that this particular term, which is a1 times xid plus b1 times yid minus c1, it will always be greater than equals to 0, because each of its term, it is positive, and as we are adding these terms, so it will be overall positive as well. So we can ensure that this particular term will be greater than equals to 0. So in that particular case, we can write as absolute of x equals to x only. So we can write that a1 of xid plus b1 of yid minus c1 is equals to d1, and similarly for a2 minus c2 is equals to d2. But this will only happen if we take a1 as greater than equals to 0, b1 greater than equals to 0, and c1 should be less than equals to 0. Similarly, the same conditions will be on a2, b2 and c2. So this is the solution for the absolute thing. There is one another problem here, that we have two equations till this point with this condition that a1 b1 a2 b2 will be greater than equal to 0 and c1 c2 will be less than equals to 0. But if you have studied the linear equations, then in order to have the unique solution when we have two equations in two variables, there is a condition, which is that a1 by b1 should not be equals to a2 by b2. So if we are asking a query, then we need to ensure this particular thing as well, that if we have asked a query with a particular ratio, then when we are asking another query, then we should not ask the query with the same ratio of a and b, because in that particular case, suppose that the output is given for the same IDs, then we have the equations which are same. So we could not have the unique solution for xid and yid. That's all from the explanation side. Let us see the code implementation of the same, so that we have a more clear idea how things work. So when it comes on to the code implementation, for each of the test case, we will call this function name sort. Now for each of the test case, we will first take on the input of n and m as mentioned in the question. In order to store that thing, that if a particular pair value of a and b is already being asked as the query or not, we will have this particular map mp. In order to store the values of a, b and d, we have used these three arrays. Now we have also used the array frequency, which maintains the count of the number of equations which we have for that particular I. So if the frequency of I is 1, it means that for that particular jump whose ID is I, we have already asked a query. And now if we asked, so this will be the second time we are asking the query for that particular index. Now to ask the query, we will iterate all the different values from the 1 to 128 for A and B respectively, because we need to maintain the thing that the absolute value of that particular thing, which is the A of X plus B of Y minus C, it should be always be positive. So we have taken that A is positive, also B is positive, and we are taking C as 0 always. Now, in order to check that this particular value of I and J, which we are taking as the values of A and B respectively, is this particular pair has been already asked or not. So if the map of this particular pair, it is 1, then we cannot ask this particular pair because it has been already asked. So we will check it by the I by G and J by G, where G is the GCD for I and J. So if a particular pair it has been already asked, so we will not ask this particular time. And if that is not the case, then we will ask the query by printing 1 followed by I and J, then 0, because we have considered the value of 0. You can have the value negative as well, because that will also maintains our condition, but for the easiness I have taken the value 0 here. And as you have asked the query, we need to update the same in the map. So we have updated that we have asked the query by of I by G and J by G as 1. Now the output for this particular query will be the index of the jump and also the distance. If the frequency of that particular jump is 0, then this is the first time you are asking the query for this particular jump. So if it is the case, then we cannot have the value of X and Y because it is the first equation only. So we need to store the value of A, B and the distance which we have obtained. So we are storing their values. Also, we are marking the frequency of that particular jump as 1, because when we are asking the query for the same jump, the next time we will have the value of the frequency of jump as 1. So if the frequency is 0, we have covered this particular case. And if the frequency was already being 1, what it means that you have already asked the query and the A, B and D are already stored in this particular array. So we have the values here. So for the first query, we have this particular values where it represents that the equation is A1 times X plus B1 times Y is equals to C1, because this particular term it is 0 only. And this particular time it is the second time we have the equation for the same values of X and Y. So it represents the equation A2 times X plus B2 times Y plus 0 is equals to C2. So now we have two equations with two variables which are same X and Y. And in order to have these values, we can solve these two equations and have the values of X and Y respectively by this particular formula. Now, as we have determined the exact values of the coordinate for that particular jump, now we can freely sanitize those particular coordinates. So we will apply the second query, which will be the sanitization query. So we will output 2 followed by the coordinates of that particular jump. Now, if this particular jump, it is the last one, so we will have the value of answer as 1. And if it is the case, then we will just return from here only. So this is the code for this particular problem. Now, one thing here, it is that how do we ensure that we have the 2n number of queries here, because there is the condition that we will ask the query for the same particular pair only once. So thus it ensures that if we loop on from the range 1 to 128 for A and 1 to 128 from B, do we have sufficient number of queries? We want that how many different possible ratios are there for the value A by B, such that A is in the range of 1 to 128 and also B is also in the range from 1 to 1, and at least this number should be greater than or equals to 2, and then only our solution has its complete proof. And in order to calculate the number of pairs which are there of this particular form, we need to calculate how many different number of pairs are possible of A and B such that their GCD comes out to be 1. Because suppose that their GCD is not equals to 1. So we can divide that particular A and B and can reduce in such a form that their GCD comes out to be 1. So by this particular way, we ensure that we will only count a pair once only. So the task now reduced to the thing that we need to count how many such pairs are there of A and B, where A is in the range 1 to 128 and B is also in the range 1 to 128, and A and B should have GCD 1, or rather they should be co-prime. Value of A is equals to 1. Then the number of different possible values for B, it will be phi of 1 only, because the phi represents the how many number are possible in the range from 1 to n such that their GCD is 1. And if the value of A is equals to 2, in that case the number of possible values for B, it will be phi of 2. Similarly, if A is equals to 3, then we can have phi of 3 as the distinct values possible of B such that their GCD comes out to be 1, and maximum we can go up to A's value is 128. Now in this particular case, the number of distinct possible options for B, it will be phi of 128. But if you see in this particular case, the value of B, it is being considered always less than equals to A, because that is the range that phi covers. Now there could be other way around. If B is greater than A, then similarly the options for B are, you would take B is equals to 1, then the possible options for A, it will be phi of 1. If B is equals to 2, then the possible options for A, it will be phi of 2. Similarly, when B is equals to 128, the number of possible options will be phi of 128. So we have finally the total number of possible options of the pair A comma B such that their GCD is 1, and also A and B satisfy this particular range are 2 times phi value of 1 plus phi of 2 up to phi of 128. Now if you calculate this particular term, phi of 1, phi of 2 till phi of 128, it comes out to be something greater than 5000. I am not taking the exact value, but you can calculate it by your own. But it comes out to be greater than 5000, and 2 times this particular number, it comes out to be greater than 10,000, which is clearly greater than the 2n queries which we require, because the value of n here, it is 4098 only. So in this way we can conclude that the distinct possible number of equations, or you would say the value of A and B, such that all of the equations which we are querying as the type 1 are all distinct, it is more than 2n. It completes the proof of our solution. Let us submit our code. We have an AC. That's it for this one. Make sure to like the video if you gain something out of it. To submit your code even after the contest. In case of doubt or feedback, feel free to leave in the comments.